So now we're going to talk about section 5.3, functions and relations. And in this section, we are now addressing parts of the first student learning outcome for the course that's been established by the state of Texas. So these are the module learning outcomes that we're going to hit in this section that support the student learning outcome. They include characterize where a relation is a function, apply the function notation, determine the x and y intercepts of a function defined by y equals f of x, determine the domain and range of a function, determine whether a graph defines a function, and interpret a function graphically. So functions, we can denote a function by letters like f, g, and h. So our function might be f of x equals 0.0825x, where x is the price and f of x is the sales tax. If we write f of 24, it means apply the rule of f to the number 24. In other words, if the rule is to multiply the price by 0.0825 to get the sales tax, then f of 24 means multiply 24 by 0.0825 to get the sales tax. So if we actually do that calculation, that gives us $1.98. So we can say the sales tax the sales tax on an item priced at $24, is $1.98. So definition of a function. A function is a rule or a correspondence that assigns each element x in a set called the domain to actually one member f of x or y in the range. The notation f of x is read as f of x or f of x. The domain is a set of all x values that could be put into the function, and the range is a set of all possible y or f of x values that can be derived from all possible x values. So where I'm using f of x and y, they're interchangeable, they're the same thing. Since the y values depend upon the x values, the x is the independent variable and y is the dependent variable. So let's turn to page 15 of our workbook and kind of giving you a summary here of just reminding you first what a relation was that we talked about previously. And a function is a more strict version. You're assuming that you have a relationship between x and y in such a way that each x can only produce a single y value in the range. So in other words, I cannot have an x value that goes to more than one y value. Think of it like a machine. If I'm putting the same input, I can't be getting two different outputs in the machine. That means my machine is not working, it's not functioning, so it's not a function. For each input, I should only get one output. So when we're asked to determine if a relation defines y as a function of x, what we first looked for is see, do we have any x values that are repeating? And if so, are they going to different y values? So I'm looking at this one here. And notice here I've got these two here that are going to different values of y. That tells me f of 2 is equal to 3 or 4. That's no good. I've got an x value that's going to two different y values. I'm getting two different possible y values. So this is not a function. So here I'm just looking at the x values, and I don't have any x values repeating. I don't care about the y values. It's the x values I'm worried about. If I'm making chocolate cake, if I'm putting a specific set of ingredients to make my chocolate cake, I cannot get chocolate cake and vanilla ice cream at the same time. If that were to happen, then things are not functioning properly. If I've got the ingredients from chocolate cake, I should just be getting chocolate cake out. However, there's more than one recipe for a chocolate cake. Maybe I have one that has a plain chocolate cake and another place that's a sugar-free chocolate cake. Both of them are chocolate cakes. So it's okay to have the same y value coming from two different x values. It's the other way around that doesn't work. So this would be a function. All right, let's try number 3. This is an extremely boring function. It's what's called an identity function. Each x value is going to a y value. So you give me a specific x value in the range, I'm getting just one y value of the function. So this would be a function. And then on this last one, well, we got a problem here. Looking at this 6, the 6 is I'm getting two different values for y. I'm getting 5 and 8, so that's no good. So this is not a function. All right, let's go back to page 13 of our workbook, and let's talk about the vertical line test. So there's a vertical line test for functions. If there exists a vertical line that passes through more than one point on the graph of f of x, then f of x is not a function. Examples are the following functions. What is the domain and range? Well, if I take my vertical line test, any vertical line I pick only hits one value or one point on the graph, so this would be a function. So my answer is yes. And this thing here goes forever this way and this way, so I think squishing this down, that's going to hit my entire x-axis. So my domain is going to be all real numbers. And similarly, since these arrows are extending on forever this way, if I squish it this way, it's going to hit my entire y-axis, so my range is also going to be all real numbers. So looking at number 2, again, any vertical line here passes through at most one point. So it would be a function. My domain, well, I can pick an AX value. This goes on forever this way, that goes on forever that way. So from left to right, it would be from negative infinity to positive infinity. Now my range, well, the only y value you get here is 2. So my range here would be the number 2. So the way we'll need to write that is with our set notation, curly bracket 2. Now if you look at this third graph, if I take a vertical line right here, going through x equals 1, I'm going to hit 2 points, so this would not be a function. It fails the vertical line test. I could still talk about the domain. Domain from left to right, starting from negative 2 to positive 2. Range, bottom to top, goes from bottom, negative 3, to top, positive 3. And we'll put square brackets since it actually includes those values. All right, let's turn the page. All right. By vertical line test, this is a function. This would not be a function because here's a line that you go through an infinite number of points. And vertical line test says this is a function. My domain here, I have an open circle, so it means I do not include that value. So I do not include negative 3 up, and that's a fill-in dot, so that includes positive 3. Range is kind of tricky. You have to kind of guesstimate here. My bottom here starts at negative 3.8 and it tops out here at 4. Domain is just a single value of 3. Range, going from the bottom to the top, is negative infinity to positive infinity. And then here, this thing stops at 2, so my domain here would be from negative infinity, because that arrow means extends forever, up to and including 2. Range here is from -6, and it never quite reaches -2. So as we put a bracket around the -6, but parentheses around the -2. All right, so let's go back to our workbook problem. So we're going to go to page 15. And we're going to do the vertical line test. So again, a graph defines y as a function of x if no vertical line intersects the graph at more than one point. Determine where if the graph defines y as a function of x. So again, can I find a graph that passes through more than one point? Or sorry, a vertical line that passes through more than one point? The answer is yes here. There's a vertical line. It passes through 2 points, so my answer is that no, this is not a function. Here, I could take any vertical line I want. This works. This would be yes. This last one almost works, except here, this line right here. I hit this point and that point. So this would be a no. All right, we were doing this in an earlier section about evaluating. Now we're putting it in, this is now a function. And we're going to be evaluating the functions just like we evaluated before in a previous section by plugging in. So I'm looking at my function here. And wherever I see an x, I'm going to plug in a -3. And I forgot to write the squared there. So again, you can work it by hand or punch it on your calculator. Let's go and work it by hand. So this is 9 plus 9 plus 1. That's 19. This next one's kind of weird because you're evaluating at the function at x equals a. All it means is that you're replacing x by a. And there's really not a whole lot you can do except to rewrite that as a squared minus 3a plus 1. That's as far as we can take it because we don't know what the value of a is. All right, let's try C. And we kind of talked about this when we reviewed multiplying two binomials. And we're going to need it here. So I'm going to plug in x plus 3. Well, that one we're going to need to FOIL out. So I'm going to write it up here. Is x plus 3 times x plus 3. FOIL, x times x is x squared. X times 3 is 3x. 3 times x is another 3x. 3 times 3 is 9. The middle terms are like terms, so I'm going to combine them. So that becomes plus 6x plus, so we get x squared plus 6x plus 9. For here, we'll need to distribute this -3. So that's a -3x minus 9. And then we have a plus 1. So we're going to go through and combine. Well, nothing to combine with the x squared. (6x minus 3x is 3x. -9 and 9, this 9 and -9 add up to 0, but then I have this plus 1. So I end up with x squared plus 3x plus 1.